In Lesson 11, the goal is no longer just to write correct Python code, but to write it in a way that feels natural, readable, and intentional. This is where technique starts to turn into style.
Exactly. At this stage, Python stops being a collection of rules and becomes a language you can actually think in, choosing solutions that are clearer and more expressive, not just functional.
The focus of this lesson is on writing Python that is not just correct, but intentionally designed. We'll move toward code that is clearer, more compact, and easier to adapt as projects grow.
Right. It's about learning when to replace repetitive patterns with more expressive tools, like comprehensions or flexible function signatures, so the code says what it means without unnecessary noise.
When we say that code is Pythonic, we're not talking about shortcuts or tricks. We mean code that follows the philosophy of the language: clear structure, explicit intent, and solutions that feel natural within Python's design.
Yes, and that's why readability comes first. If someone else can understand what the code does at a glance without mental gymnastics, you're probably on the right path. In Python, clarity is always valued more than being clever.
List comprehensions are a compact way to build new lists by expressing the intent directly. Instead of focusing on the mechanics of looping and appending, you describe the transformation you want in a single, readable line.
And that's the key difference. The result doesn't change, but the code becomes clearer. When the operation is simple and linear, a list comprehension lets you see the logic immediately, without getting distracted by boilerplate.
In data analysis, list comprehensions are especially valuable because they let you transform and filter data in a very direct way. The logic of the operation stays compact and visible, which makes pipelines easier to reason about.
And that has practical consequences. When the transformation fits on a single line, there's less room for accidental mistakes, and you can focus on what the data is becoming instead of how many steps it takes to get there.
Lambda functions are a Python feature for very small, focused pieces of logic. They let you define a function in a single expression, which is useful when the intent is obvious and the operation is simple.
The key is restraint. Lambdas work best when they're short-lived and easy to read, like passing a small transformation to another function. As soon as the logic starts to grow, a regular function becomes the clearer and more Pythonic choice.
In practice, lambdas are often used as small transformation functions. Here the lambda takes each value and returns its square, making the transformation explicit and localized to where it is needed.
What's important is the pattern, not just the syntax. You'll see the same idea later in data analysis workflows like Pandas apply, feature engineering, and model pipelines, where short transformations keep the code compact and readable.
*args lets a function accept any number of positional arguments. Instead of fixing how many inputs a function can take, everything is collected into a tuple, making the function more general and reusable.
This is one of those tools that really changes how you design functions. When inputs may vary, *args helps you avoid writing multiple similar functions and reduces repetitive code.
Kwargs works like *args, but for named arguments. Instead of a tuple, Python collects everything into a dictionary, so keys and values are preserved and can be accessed explicitly inside the function.
This is especially useful when functions need to stay flexible, but still readable. Named arguments make the intent clearer, while kwargs lets the function adapt without constantly changing its signature.
Together, *args and kwargs make functions adaptable. They let you design interfaces that can handle changing requirements without constantly rewriting function definitions.
That flexibility pays off in real projects. You can simplify APIs, accept new options over time, and refactor code more safely, all without breaking existing calls.
Here everything comes together. This example shows a higher-order function, a function that takes another function as input and applies it consistently to a collection.
You can see how list comprehensions and lambdas work naturally here. This pattern is extremely common in data science, where transformations are passed around as simple, reusable pieces of logic.
This slide marks the end of the Python base course. At this point, You've built a solid foundation and learned how to read, write, and reason about clean Python code in a structured way.
From here on, Python stops being the goal and becomes the tool. This is also where we pause the base course. The advanced course will start soon, and it will focus on applying these concepts to real data analysis, statistics, and machine learning problems.